We are on question 42 here, but before I have you look at this question, and this is like one of the more challenging questions I've seen on the prep that they have. I just want to talk about, so this is going into the nonlinear functions, which are mostly quadratic functions and exponential functions. So again, I don't have page numbers on this, but the problems go in order consecutively all the way through. So we're on the page with problem number 42. All right, so dealing with quadratic functions has three forms. And just a really quick overview. Okay, so probably the easiest form to work with would be vertex form. Vertex form of a quadratic function looks like the following. So f of x is equal to a is some multiplier times x minus h quantity squared plus k. And in this form, the vertex is the point hk. That's part of why it's so easy to work with. Okay. The second form that you might see is general form. General form is a pretty common form where everything's expanded out. Okay. So in the expanded form, you have ax squared plus bx plus c. And you can still find the vertex using this. Again, the vertex is going to be one of the key points that are used in a lot of the SAT questions. And in general form, the vertex can be found, you see it up here as well, by taking negative b over 2a and then evaluating the function for that number. Whatever that number is, plug it into the original equation, and that's going to give you your x and y coordinate of the vertex. And then the final form that you might see is a fully factored form. So you have the expanded form in general form. You have the factored form in this intercept form. And that's designated as a times the quantity x minus p times x minus q, where p and q are the x and y, or p and q are the x-intercepts. And so with regard to the intercept form, the vertex of a parabola is halfway between those two x-intercepts. So you can find the x-coordinate by taking p plus q and dividing that by 2. And then if you evaluate your function at that number, you'd get the corresponding y-coordinate. So just as a review, these are your three forms and the ways to find the vertex from each of them. Okay, and so that's going to be like a key to working with quadratic functions. The other element that the SAT tests more than what we've ever covered in our school or our classes here is the SAT is also going to expect you to understand how the discriminant works. Again, we haven't focused a ton on that. But the discriminant happens when you, or can be found when you put your quadratic function in general form. And you just take the part of that would be in the square root of the quadratic formula. And remember, the quadratic formula would be negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, the reason I split it like this, you probably haven't had it exposed as being split like this, but I split it like this because in this form, if you want to find what your x-intercepts are from general form, you can just set the quadratic function equal to, or quadratic formula equal to 0 and solve. Well, notice the form. This is your x-coordinate of your vertex. And then plus or minus whatever that shift is away from that, and that's going to give you your p and your q values, right? It's going to be the square root of b squared minus 4ac over 2a to the right, and that same distance to the left of that vertex, and that's where the x-intercepts will fall. Okay, and so this portion here under the radical, this is your discriminant. Okay, and so the quadratic function, if you look at the discriminant, it can tell you whether you have no solutions, if that's a negative number. If it has one solution, where that would be equal to 0. And then if it has two solutions, where that's some positive value. And so the SAT does test your ability to work with all of those concepts regarding quadratic functions. All right, so with that said, I'm just gonna talk through this first one, although actually I'll give you like a minute or two to try it. Okay, so try number 42 on your own. Okay, this is a really challenge. This is considered one of the more challenging types of questions that you might come across. Okay, but I want you just to see, like, how would you start this? I might not give you enough time to finish it, but see how far you can get or what you can do with regard to this. All right, so I'm going to go ahead and start talking through it. Again, like, it's great if you've made some progress on it. But again, this type of a question is one that I've never seen in a classroom setting. So it's possibly like a new way to kind of be exposed to this information. So the first thing they tell you is you know that the vertex is 9, -15. And it tells you that there's 2 solution points. So does this graph open up or down? If it has 2 points that it crosses, then you know it opens up, right? So opening up means that this A value has to be positive. And so that's the first thing, the first piece of information that you're going to use in this problem. Okay, you know A has to be a positive number. So what you can do to find this, since you are only given 1 point, and that point is HK, what I'm going to do is I'm going to look at this form of the equation. Right? And so if I rewrite this equation right here, so if I take, here's my equation, instead of writing it in this general form, I'm going to write it as y equals A times the quantity x minus h, which was 9, squared plus k, which is minus 15. And I'm going to rewrite it in that general form. So now I have numbers to use other than A. And so if I expand this out, I get x squared minus 18x plus 81 minus 15. And then I'm going to distribute my A through here. I get ax squared minus 18ax plus 81a minus 15. So here is my equation now written in general form. And it includes my A value. All I know about the A value at this point is that A has to be a positive number, right? All right. So the next thing that you can determine from this is you want to find out which of these possible values here in the answer choices could be the total sum of A plus B plus C. Well, here's A. Notice now you can find B is the coefficient of X. C is this whole constant, right? So this is your A value, this is your B value, this is your C value. So what you would then need to do for this is you need to combine all of those. So we get A plus a negative 18A plus 81A minus 15. And remember, one of these has to equal this quantity, right? So if you continue to work through and combine all your A's here, so if we have 1A minus 18A plus 81A, so we have a total of 64A, and then the minus 15. And again, that has to equal one of those values, and what else do we know about A? It has to be positive. Okay? So basically at this point now, what you would do is you would think of, or you'd test, which of these answer choices right here could fit into this box and allow you to take that equation, solve for A, and have A be a positive number. So let's kind of look at what that is, right? So I'm using this box as one of these answer choices. I'm going to add 15 to that, equals 64A. Going to divide by 64. So what I'm going to see is I have some unknown. Now remember, on Desmos, we can use a slider. Okay? So I'm going to give it just a random letter here. I'll call it G, just because it doesn't interfere with A, B, and C. But if I took G plus 15, and I divided that by 4, and I want to see, when I test these numbers here, I need this whole thing to be a positive number. So if I test a negative 24, do I get a positive number right here? No. If I test the next one, negative 15, Do I get a positive number? No. If I test negative 18, do I get a positive number? No. And if I test negative 13, do I get a positive number? Yeah. Okay. Not, again, this is not the most intuitive type of question, but this illustrates a little bit of sort of the advanced concepts involving quadratic functions that they may ask you. Okay. All right, so again, that's part of why I just wanted to talk through it so you see. It's based on the things that we've done in school, but we've never had questions like that are quite that intricate involving the quadratic function. All right, let's try one that's a little more consistent with what you have looked at. Try 44, see if you can answer that one on your own as well, please. It is still a hard question, though. It's still on the harder side. For this one, I'm going to show you a mathematical way that I would approach it, and then I'm going to show you the graphical way as well, because, again, you have access to that graphing utility. So this problem right here, you have a vertex, and you have an x-intercept. And so that means that this is likely the form that you would be thinking in terms of, the intercept form. Right? And if you think about the graphs, so if you have a vertex down here, and your parabola intersects at two places up here, this vertex is halfway between those two intersections. This is why the vertex can be found by taking the average of P and Q. So if you say this is where P and Q intersect, the x-axis, then this vertex right here is going to be the average of those for the x-coordinate. What that means is that this distance right here, from here to here and here to here, that is the plus or minus square root of b squared minus 4ac all over 2a. That's what that distance represents. It's the distance from that vertical line passing through the vertex to each of those x-intercepts. And so all we need to know for that is, in this case right here, is that that distance is equal for both sides, to the left and to the right. And so if we were to think about what we have right here visually, we have a vertex at -6, -4. Again, it doesn't have to be like perfectly drawn, but has that realistic idea. You have two x-intercepts, so you know one is -41/4. So the first thing is to think, 41/4, is that to the left of or to the right of this vertex? So we see it's -10, a little bit more than that. So right here is the known value. This is -41/4. And so what that means is that your parabola is going to open like this. And so this point right here is going to be the exact same distance away from this vertical line as the -41/4. So if we find what is the distance between these, so the distance between 2 points is the absolute value. Well, actually, let me show you on this. So you can find the absolute value symbols right here. And you can also use what I typed in. You can use ABS if you're doing a keyboard. It might be easier to find it that way. But if you type in the difference between these two coordinates, so -41/4 minus the known coordinate here, -6, and you find the absolute value of their difference. So you know that this distance here is 4.25, which means the other point is also going to be 4.25 units away. And so if you find what is -6 plus 4.25 in that direction, that gives you your answer. Notice all of these answers here are in fraction form. My answer is displayed as a decimal. On the left side of the Desmos calculator is this little fraction box, or icon. If you click on it, it'll give you your answer in terms of the fraction. So -7/4 is your answer for this problem. All right, there's another way that you can solve this question a little more visually, and it involves sort of the quadratic regression. And remember, you need one more point than the power or the degree. So for a quadratic, you need 3 points in order to find the regression equation. And you have 2, right? We have this point -6/4. So I'm going to go in, I'm going to create a table. I'm going to type in -6, -4. I'm going to type in, I have an x-intercept. So I have the point negative 41 over 4. And the y-coordinate is going to be 0 on that, right? Okay, and then I have one other point that I need to test. Okay, I'm going to call it A. But I want to see where it fits or where it lies on the graph, right? So what I want to do is I want to use my quadratic regression. So y1 is similar to, and you can use any of those three forms that I talked about. Any of these three forms right here, vertex form, general form, or intercept form, I can use all of those. Okay? So whichever one you want to choose, again, really what I'm looking for here is I'm trying to find an equation that fits this image right here. Okay, so if let's say I use, now anytime you type this, and let me go back, when you use x's or y's, you need to display it with a sub 1, the subscript 1. I'm going to go back. Let me change this number or letter to something else. It's interfering with the A in the front of the expression. Sorry about that. Let's go back and I'll use G again so it doesn't interrupt anything. There we go. Okay, so if we go back and we test these, does everybody see what happened there? It's because I used the same variable that I used in the equation. It kind of complicated that. So if we go back and test the 29 over 2, notice this doesn't open the way that we want it to, right? Or it doesn't pass through the vertex here of -6, -4, right? We need our h and our k values to be -6 and -4. So if I go in and I test 5/2, now it looks like it's passing through, right? But when I look, my h and k values, again, it's not the -6, -4 values that I need. So I test 41 over 4. Still not the h and k values are not where I want them to be. So I test my final set of points here, -7 over 4. And now when you look, -6, -4, you get your HK values that you were expecting to find. It passes through all the points that you were expecting. So this visually can confirm using the graph as well. Okay. All right, let's jump to the next problem, even problem 46. This is one that you should be able to answer pretty instantaneously, right? When you look at this, this is exactly one of the way that you would want to write it so that you could find the x-intercepts. Just set each of those factors equal to 0. So x plus 4 equals 0, and x minus 6 equals 0. And that's going to give you your two intercepts. So either of those answers would work, -4 or 6. And if you aren't sure, again, if that isn't something that you are familiar with, if you just type this function in, it confirms what you have. You look at your two x-intercepts plotted on the graph of it, and you have your solution. All right. So again, I encourage you to look over the odd questions too. Quadratic functions are one of the more highly likely types of problems that you're going to see. The other highly likely nonlinear type of function that you'll see will be exponential functions. Okay, and so just really quickly, looking at exponential functions right here, and you have a general form of them where a lot of times it's based on time. Okay, or actually I'm going to go through, let me put it in terms of x's. And so if we look at just the general form of an exponential function, this is sort of the pattern. And a is some multiplier here. This is usually, or this is your initial amount, the value at time 0. Okay, and then b represents the factor, either growth factor or decay factor. So it's usually going to be 1 plus a number if it's growth, and b is going to be 1 minus the rate of change or the percent change if it's a decay. Okay, and so those are your two values. So that value that is b is either going to be usually like a little more than 1. So if your R value is the percent as a decimal, okay, so it's the rate of change as a decimal. And so it's either going to be like probably just a little more than 1. So 1.3 would be a 30% change. 1.03 would be a 3% change of growth. And if you're decaying or reducing, it would be 1 minus. So 0.7 is 1 minus 0.3, meaning it's a 30% drop. And 0.97 would be a 3% drop, right? It's 1 minus 0.03. And so that B value is going to be the growth or decay factor, and then the power of X. Okay? So based on that, see if you can answer question 48 if you haven't already answered that. All right, so here it gives you the quantity at time 0 is 21. That's your A value. So you know that it's going to be, the function is 21 times 1 plus or minus. It's a decrease, so it's going to be 1 minus the percent as a decimal is 0.34, and then all to the power of whatever the variable is here, X. And so there's your answer, and if you simplify that, you get this option C for your solution. Okay, but it's pretty consistent. You will likely need to, this would be the case of interpreting an exponential function and figuring out what the different elements of the function itself represent. Right, this power right here is the number of times that change happens. So often it's like per year, so it's represented in years. But if it says that something happened monthly, and then it wouldn't just be, like that change wouldn't be happening just 1 time a year, right? It would be happening 12 times a year. So depending on the units that they use, you might have to interpret what this power represents. And so I think looking at this next question. I want you to see how you would interpret this problem, and then I'll talk a little more about what that power represents if it's a fraction. All right, so one of the potentially confusing things, it's probably glossed over, but I wanted to explain it. One of the potentially confusing things is that they give you a function that is happening in months, okay, but it's asking you to find it in years. So this is that idea, right? So notice up here that if the function has that divided by 12, and what that means is it takes 12 of those whatever time units, whatever in this case, I think it says it's M, okay, whatever time units M represents, you need 12 of those. Whatever the denominator is, you need like that number of those to happen before one of the compoundings, one of the doublings or whatever happens. In this case, it's a drop by a certain percentage happens. It doesn't happen once. Based on this function, it has to be 12 times before that 1 power of M is applied. And so all that means is that this is the number of months for one growth or decay factor. And so in this particular case, because they changed the units on you, so it's asking you to find it per year. If you were to model that function per year, it wouldn't have that division by 12, right? Because that's for months. For years, it would just be to the power of t. So, I mean, like I said, that for this problem, it doesn't really apply, and it's sort of glossed over that those are 2 separate units, but that's what they represent. Okay, so if you have something where you have a times b to the t over 7, what that means is it will take 7 years for that to happen. Okay, and so when you get to like the half-lives, some of the things that you might have seen, a half-life would be something like this. Okay, and if you had a problem written like this, how many years would it take for this radioactive material to decay by 1/2? And the answer would be 34 years. Whatever this denominator of that rational power is going to be the number of time units that need to go by for the one compounding, the one growth or decay factor to apply. All right, now that's kind of a side note, just because it came up or showed up in that problem. For this, what you're really looking for is how do you create this growth or decay factor? So 0.64, is that growth or decay, first of all? It's decay, it's decreasing, and 1 minus what value gives you 0.64? 0.36, and that represents what percentage? 36. And so that's what you're being asked for in this question. Again, I just wanted to point out what that fraction means if you see it show up. All right, so actually let's try this question 49 here really quickly, because it's based on what I just talked about, and it's an easy answer if you understand the concept. So see if you can answer that question here really quickly based on what I talked about previously. Okay, so you see the growth factor is 2, right? It's doubling. So how many of these time units, which are measured in minutes, have to pass for doubling to occur? And the answer would be just the denominator, right? So that's where you will see it potentially if it shows up in that the rational form of the power. All right. In addition to working with quadratic functions and exponential functions, the other highly tested concepts involving nonlinear functions are polynomial functions with n behaviors. You just need to be familiar with the n behavior. Okay, so when you look at an odd degree function with a positive leading coefficient, the dashes mean something's going to happen in there. Sometimes they have turning points, but an odd degree with a positive leading coefficient is going to go up and to the right, down and to the left. If it's an odd degree with a negative leading coefficient, that gets reflected and switched. If you have an even degree function, right, then if with positive coefficient, the end behavior is it goes up in both the left and right, right? Again, the dashed lines just represent something is happening in between those that are based on other rules. But just looking at the even degree with a negative leading coefficient is going to go down both the left and the right behavior. Okay? So when you look at this right here, you know based on where the end behaviors lie on this graph, you know that this graph is going to have an even degree, right? It's going to have, the highest power of x is going to be an even number. And you also know that it's going to have a positive leading coefficient. The other thing that you know about graphs just by looking at them is multiplicities of zeros. Have you guys talked about those yet in classes? Okay, so you know when you look at these x-intercepts right here, here, and here, you actually know the factors associated with those intercepts, right? It's always x minus that number. So x minus a -4. Here we have x minus a -2. And here we have x minus 2. So those are the factors that are associated at those zeros. And then the path, the pattern of how the graph passes through those points tells you their multiplicities. It tells you whether it's a power of 1, 2, or 3, and that's kind of where we're limited to what you'll be tested on. If a graph just passes straight through at a point, it has a multiplicity of 1. Okay. If a graph bounces off of the x-axis, it has a multiplicity of 2. And if the graph snakes through it, so it kind of passes through in that curve, it has a multiplicity of 3. So basically, if you're looking at this right here, you have some a value that's a positive number, but this right here is what your function, the pattern of your function. It's a times x plus 4 times x plus 2 squared times x minus 2 cubed. Okay? So based on what the graph looks like. Okay, so let's look at both of these problems here. Let's start with 51 based on this. So looking at those rules that we just talked about right here, okay, can you determine which of these functions would be the correct function for that graph? You see these three intercepts, right? So -3 is x minus a -3. You see this is just x minus 0, so just x. And this one is x minus 7. And when you look at these, it passes straight through x minus 7, passes straight through x, or the x plus 3, and it bounces off the 0, right? So you know that has a multiplicity of 2. Add these powers together. 2 plus 1 gives you 4. You're expecting this to be a negative leading coefficient, but an even degree. We added those together. It is 4. That's consistent with what we would expect. So when we're looking at these problems, we need it to have an x squared, so I can eliminate those two. It needs an x plus 3, so I can eliminate that. It needs an x minus 7. This one has that as well. And so you can find your answer either by process of elimination or by actually finding the one that models that situation. All right, I want you to solve this last question right here. This would be finding equivalent forms of equations is also something with nonlinear functions that you might be asked to do. A lot of times it will be ones with many variables and in a rational form. But see if you can determine which of those are equivalent ways to write that given expression. So one of the things when you're working on SAT questions is that a lot of times the way that sort of the math training happens can make you do things that are less efficient, like working through a problem, right? Like you might want to always go through and do the math of solving something rather than using the calculator and getting an answer quickly. Okay, so this is one of those things too, where when you look at this problem alone, you may think that you cross multiply, distribute the p, you start to isolate different parts of this, but look at the answer choices. You know that this 7y or 7j plus 3 has to be treated as just one unit, so you don't even need to think of that anything other than just one binomial unit that you can manipulate. So look to isolate that. If we cross multiply it, we get 7j plus 3 times p is equal to k. And then to isolate that whole thing, just divide by p, and we've done it. We don't have to distribute through. You don't have to do any of that. It's already done in just those two quick steps, leaving the only answer choice, this option C.